Chapter 2, Exercise 2.97. The iodine molecule can be photo-dissociated into iodine atoms in the gas phase with light of wavelengths shorter than about 792 nanometers. A glass tube contains 4.2 times 10 to the power of 17 iodine molecules. What minimum amount of light energy must be absorbed by the iodine in the tube to dissociate 19% of the molecules? So here's the plan. We need a photon with this wavelength to dissociate just one iodine molecules into separate iodine atoms. And now we have this many molecules. We need to dissociate 19% of this many molecules. So I'll show you the calculation here. We have this many molecules, alright, but we need to break just 19% of the molecules. 19% is 0.19, and then multiplied by the energy required to just dissociate one iodine molecule. Alright, so over here, this is the energy required to dissociate one iodine molecule. How do we get this information? Well, it's not given in the question. It gives the wavelength of a photon that can dissociate one iodine molecule. This is a wavelength, 792 nanometers. We just need to convert this to the energy of the photon. The equation is Hc over lambda. Hc over lambda here. H is the Planck constant. You can look up its value in the book. Speed of light. Finally, lambda, do not just use 792 because I used the SI units for every single value here. I need to also use the SI unit of wavelength, which is meters. So this is actually 792 nanometers. 1 nanometer is 10 to the power of -9 meters. Therefore, I need to convert it to meters by multiplying 792 with 10 to the power of -9. I shift the decimal point, 2 places here, and therefore -9 becomes -7, and then I click the equal sign, and then you'll see Mastering Chemistry will do this. The number of molecules, 19%, Planck constant, speed of light over lambda. And if you just use the speed of light over lambda, you'll get frequency here. But let's look at the final result, 0.0200. What's the unit? It's going to be joule, because the question is the energy, and I used SI units in my calculation. So 0.02. Let's keep 3 sig figures, 3 sig figures, 3 sig figures, 3 sig figures. So maybe this, and then joule is the SI unit of energy. Alright, submit. Okay. Now let's look at Mastering Chemistry solution. Alright, first they compute the number of molecules that need to be dissociated, 19% of the total number of molecules. And then for each molecule you need this much energy, Hc over lambda, Planck constant, speed of light, the wavelengths on the bottom, get this amount of energy, and finally multiply this amount of energy by the number of molecules that need to be dissociated. and we get the correct answer.